All right. Hello to all you new geometric fact finders. This video that we're going to do right now is called Is the First Reason Always Given? So, the way we've been writing proofs, kind of some steps that you can kind of count on that kind of are always going to be the case, or things I'll tell you to do first is usually what I tell you is to state your givens is the very first step. Start that with trying to prove your fact. And then the very last step, of course, is just going to be this proof statement right here, right? So we know that the proof thing is going to be the very, very last statement. So I'm not going to have you focus on that because the last statement is always going to be the thing you're trying to prove. The question for you is, well, how do we start this proof? And can we start with writing given right there? Now, if you've been paying attention in class, what I've been telling you is that really 90% of the time, given will be your first reason. So let's take a look to see if given is going to be the first reason on this particular proof right here. Quick reminders on proofs and the structures of what we're trying to do. Again, this is given and then it says proof here because we're trying to prove a fact. And so if I'm going to read this, the given is kind of the hypothesis, the part of that comes after the if in an if then statement, and then the prove statement. Prove is the conclusion. That's the thing we're trying to prove here. So let's just say this is an if then statement real quick. If we have angle AOD as shown right here, then we can conclude, we'll be able to prove then measure of angle AOD would have to equal measure of angle 1 plus measure of angle 2 plus measure of angle 3. So this here, right, if we're trying to think about what we're trying to prove here, is this here is not only if we just have 1, but 2 and 3 adjacent angles next to one another, that this largest angle here would be the sum of 3 angle measurements here. So this is slightly different than the angle addition postulate because the angle addition postulate is written for 2 angles. This here is written for 3 angles. Angle addition postulate is part plus part equals whole, right? The part of the angle plus another part of the angle equals the whole angle. The difference in this one is that this is a much larger angle that's composed of 3 adjacent angles. Anyways, that's why this isn't a postulate. This is something that you're proving right now. And you'll probably have to use angle addition postulate in here. Anyways, I just read through it to get an idea of, it's always a good idea to get to know what you're trying to prove, and that's kind of it. But getting back to kind of the structure of this, the given here, it comes after our if, but I've been calling it something different recently too. I've been calling this the given premise. Right, given premise. A premise is just kind of like a situation. It's a beginning fact that we have that we're going to build on, right? Build on here. So our given fact here is that angle AOD is as shown. Interesting. So we have the given premise, and then the given premise is just pointing us to this angle AOD. And what is angle AOD? What's over here? What have I been calling this over here? I've been calling this the given diagram because this is our given diagram. So what's interesting about this one, what's different than some of the proofs that you've seen so far, and almost all proofs here in the book don't do this, but what's happening in this particular one, what makes this one really unique is that the given premise is just pointing us to the given diagram here. So there really isn't a given premise. A given premise here in the given statement is usually like a fact beyond what's shown to you, what's presented to you about this diagram that we can use in our proving here. So for this particular situation, they're just pointing us to the diagram, and the given statement that's right here is pretty much worthless, just points to the diagram. So the thing is, there's no reason to write angle AOD as shown down here and state given as our first reason, because angle AOD as shown, there's nothing we can prove with that. There's no postulate we can use for just angle AOD being shown. That's not a definition or anything like that. So we need to say something else. So this is an example of a situation where it's not always going to be given at the beginning. We need to come up with another reason. So maybe we can look and see and really inspect here of what's happening in step 1. Okay. Step 1 is saying it's making the conclusion that angle AOD, so they're kind of working backwards here already. Remember, if your given premise here is, it doesn't lead you anywhere, right? You run out here, you look to the proof statement. And the proof statement here, what we're ultimately trying to prove, we're trying to say something about measure of angle AOD. What's the thing that we have that we know about measure of angle AOD that we can actually use, right? This larger angle here, we actually say something using this larger angle right now. Well, we can say that measure of angle AOD equals, look, they're saying measure of angle AOC plus measure of angle 3. which is shares this side of that angle and this right here. So here, what they're saying here is that we have a part plus part. Okay, look at here. This part of the large angle, the one in yellow, and then this other part adjacent to it make up the rest of that large angle right there. So we have a part plus part equal to whole statement right here. And when we have a part plus part equals whole statement right here, that's an assumption, right? That's an assumption built off of it. And if it's an assumption, it's a postulate. So my reason here is not given, okay? It's not given because we're not using the given premise. We're using the given diagram and we're spotting something, a relationship here to make a conclusion. What we're spotting here involves the angle addition postulate. So what we can spot if we look at a diagram, if you just look, remember, if you just look at the diagram, then and you notice that you have a part plus part equals whole relationship, you can take what's in the diagram right here and put that part plus part equals whole relationship here and then say the reason, right? Reason is angle addition postulate. All right, that's step one. We might as well write the rest of the proof together because we are here right now. Measure of angle AOC. So now we have AOC, which is right here. Angle AOC plus equals measure of angle 1 plus measure of angle 2. I'll buy that, right? Since this angle here in green is the large angle, but then that's composed of angle 1 and angle 2. So we can add those measurements together, get the measure of angle AOC. And that's, again, a part plus part equals whole assumption that we can do that. If the sum of the whole angle is equal to its two parts added together. So angle addition postulate just written for two angles being added together, not three angles added together. That's why this is going to be something that we're going to prove. So this is the angle addition postulate. You have to read these postulates very literally, exactly as they say. An angle addition postulate is a part of an angle plus another part of an angle equals the whole angle. And those are in terms of measurements here. All right, angle addition postulate here, angle addition postulate here. What's the third step? Well, the third step, they gave it to us here. Remember, the very last step of a proof is going to be this proof statement right here. So our ending statement that we're proving as fact is this: measure of angle AOD equals measure of angle 1 plus measure of angle 2 plus measure of angle 3. How did we get there? Would you have been able to figure out how to get there on your own without kind of knowing that's here? Well, let's check it out here. We got measure of angle AOD, and nice, that is right here. So that's good, right? That's good. Measure of angle AOD and measure of angle AOD here. So I know that this is going to be the equation. Equation 1 just modified down here. So looking at it here, step 1, how did my equation change from step 1? You got to be perceptive, really pay attention closely to this. How did my equation change from step 1 to step 3? Well, it looks like I knew that measure of angle AOC, which is right here, it's also equal to this, measure of angle 1 plus measure of angle 2. So I can take the measure of angle 1 plus measure of angle 2, and I can replace measure of angle AOC. Okay, so look at this here. These guys just swapped, right? These guys just swapped here. We took this measure of angle 1 plus measure of angle 2, swapped it into measure of angle AOC, and then here we have measure of angle AOC is right here, but we're saying measure of angle 1 plus measure of angle 2 equals measure of angle 3. So our solution to this one is here. We knew that this thing equaled something different, so we substituted these two quantities into this larger equation right here. So this is not transitive. This is substitution. So this is the substitution property of equality, POE. And that gets us to proving this as a fact. So beyond the angle addition postulate, which is part plus part equals whole, so two angles that are adjacent to one another, we can add the two measurements to get the measurement of the whole angle. We can now do this with three angles, right? We can do this with three angles, and this is proven based on the angle addition postulate here, okay? So to summarize, right, here, why isn't the first step given? Okay, why wasn't it given? Okay, why wasn't it given? It was something different there, okay? And the reason is that we spotted a part plus part equals whole, 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 part plus part equals whole relationship in diagram. And when we notice that, we can use the angle addition postulate. Okay, angle addition postulate. is a great way where we can introduce a rule from the actual diagram that's not in the given premises. We're picking something up from the given diagram that we know has got to be true because we've assumed the Anglo addition postulate is true right there. Okay, so a common thing, right? A common thing. This guy comes up. Anglo addition postulate is a common first step. So it's a common first step of a proof. That's not given. That's not given. There aren't going to be very many steps that you're going to do at the very beginning of a proof beyond Anglo addition postulate and given, and then also segment addition postulate. That's a very good one to start a proof off with because you just need to notice it in the diagram, then use it as a first step. We'll get a few more as the year goes along and we prove more facts and we get more facts. We'll have some more ways where, hey, we spot something in the diagram, we can say it as step one and either save our given premise for later or maybe our given premise is useless like there was in this one here. Email me if you have any questions. Take care, guys. Bye.